2021, the 11th Fringe workshop organized by ESA for Science and Applications of SAR Interferometry. And without further ado, I would like to invite Maurice Bourgeot, the head of the Department of the EO Science Applications and Climate Department in ESRIN. Please, Maurice, you can open the workshop.
Yes, good morning. Thank you. Thank you, Marcus. Good morning to all. It's a great pleasure to be with you today and, to make this opening for the FRINGE 2021 workshop. Let me show you a few slides here about what FRINGE is about and, our future missions in the coming years. So if I could have the first slides, please.
Ryan.
Excuse me, there's some slight technical issues that we are sorting out.
E come devo fare io dal mio? Cioè, come devo fare? Ok. E come la share?
Okay, we are getting there. Okay, I think the technical problem has been solved. So Maurice, you can unmute and go on.
Very good. Can you hear me now? Fantastic.
Yes.
So sorry for this, small technical issues here. We are back on track here. So as I said, it's a great pleasure to welcome you for this international ESA organized workshop on FRINGE. It's the 11th that we are organizing in terms of together with other science and application interferometry. This workshop should have taken place last year in Delft, I recall, but because of COVID, we decided to postpone to 2021. So if I could have the next slide, please. Hopefully this will work here. Yes, that's the series of the FRINGE workshop. We started in 2003 here. The last one we organized was in Helsinki in 2017. As I said, we should have had the one in 2020, and it's now taking place today and the coming days. Please, next. So very glad to see that, even though we cannot meet physically here, we have managed to attract a large number of participants. Actually, the figures that you see, 793, I was just told this morning, we are at 869 registered participants here, with very spread from 67 countries. Of course, many Europeans here. You see Germany, you see Italy here, but as well colleagues, a large number of colleagues from the US, but also from China, that I do welcome very much to this event here. It's all online here. We will have several sessions here, two organized by ESA, where we show the next activities we have, or the next satellites we have in terms of SAR satellites here, and of course quite a few posters here. You see the topics that we'll cover in the event here. They were well illustrated on the website and when you register and you wrote your paper. Please, next. Okay, the objectives of the 2021 Fringe workshop are shown here. Of course, is to bring the community together, the one involved in informatics are here, but also on our side is to present the latest on our mission, or the Sentinel-1 here, and what's planned in the future in terms of Copernicus, but also in terms of Earth Explorer here. The meeting in 2017 made recommendations, and this is also the one of the topic for this week here, where we look forward to recommendations from the Fringe 21. But we'll go through the recommendation from 2017 together with you. And as I said, it's really also to listen to your feedback here. It's very important to discuss with the user community involved in INSAR here, and to get your recommendation. I could get the next slide, please. We'll remove, there's a small window here. Next slide, please. Very good. So, this, I think most of you are familiar with the three main families of satellites that we build at ESA. Closer to the Earth, if I may say, it's the science, the Earth Explorer, dedicated really to explore new science question. Copernicus, or the application, a very successful series of satellite that we developed with the European Commission. European Commission is, of course, in charge of Copernicus, and we are implementing the space component, including the satellite. The last family, meteorology, is less relevant to the SAR community here. But of course, there are some, atmospheric effect here, for which meteorology it plays also an important role, and it's done together with our colleagues in Darmstadt from EUMETSAT. So what we'll be talking about, in the coming days here, at least with the ESA satellites here, of course, Sentinel-1A and Sentinel-1B, which are flying. And if you press one more click, okay, what's coming up in terms of biomass, Sentinel-1D and Sentinel-2D, all these missions are being built, missions approved and being built. And whereas the last, if you could click one more time, you will see, in yellow, things that, are on the process or very likely to be approved, like the Rose-L missions, the Sentinel-1 next generation, but also Harmony, which is, a candidate mission for the Earth Explorer number 10. So you see, a very nice mix between brand new research mission with biomass and hopefully Harmony, but also with the Copernicus, with the satellite, with the Sentinel type of mission, plus the new type of mission, the Rose-L, and I'll come back to this later. Next, please. Just a few examples. Okay, this is Sentinel-1 here. Sentinel-1A was launched, if not mistaken, 2014. Sentinel-1B was 2 years later in 2016. The two satellites are working extremely well, together with, the two satellites. We have a 6 days repeat time. Here you have a very good example what unfortunately happened in China here, but how reactive the Sentinel were to provide this interprogram in descending path, the earthquake took place more than just a week ago or 10 days ago here. Just to show, to illustrate, but I'm sure Pierre Potin will come back later here on the Sentinel-1. In terms of the open access data hub, it's more than 450,000 users here. You see the amount of data which have been, downloaded and the products available. So it's just a rate of 7. So each of the product has been downloaded in average 7 times here. And Sentinel-1A and 1B are data that are made available also to the international charter on space and major disaster. And here, this is the example here of what's done with this interprogram. Please, next. Okay, I talked to Biomass about Biomass. It's an Earth Explorer. This will be the first P-band, so for around 450 or 440 megahertz. So, a very long wavelengths to penetrate through canopy here. And, a fully polarimetric missions here, extremely interesting. People have been dreaming since years, if not decades, about, a spaceborne P-band. And this will become reality in 2023 here, if everything goes well here. 2 years from now. Primary mission objectives, of course, it's to look, as the name indicates, above ground biomass here, but also to measure the changes in the forest stock here over the duration of the mission. Of course, we'll be looking, like all explorers here, at secondary type of objectives here. P-band will be able to penetrate substantially, especially when you don't have too much moisture here. So for deserts and other applications here, but also to look at topography and the dense vegetation and other type of objectives here. Next, please. Harmony. Harmony is the mission which is currently being studied in the frame of the Explorer program. We just started the phase A here, and will be finished, by mid next year of this phase A. And if everything goes well, this mission will be recommended by the Advisory Committee on Earth Observation. And our program board on Earth observation should take a decision about E10 towards the summer or September next year here. And this will be one of the main missions that we will bring to the attention to our member states for the so-called ministerial conference in 2022. Harmony is, to fly together with Sentinel-1D here. By the way, Sentinel-1D is supposed to be launched around, in the time frame, if I'm not mistaken, 2025, 2028, since 1A and 1B are doing extremely well here. And this will be 2 companion satellites in a loose convoy formation. And then we'll be, getting the signal from Sentinel-1D, but will be also looking with their own instrument. The foreseen launch is in 2029. And you see, if you get to click again here, you see the main applications. If you click again, okay, about, the type of resolution, sub-kilometer scale here, different types of information, but we will be looking at 3D deformation vectors here, looking at, dynamic volume changes here in, wind polar, but also in montane areas here, and to look at, information about, sea ice motion and others. So an extremely fancy missions here. So it's an Earth Explorer before, they could go to Copernicus. So it's, coming hopefully to be launched in 2029. Assuming the mission, okay, this is not a sure thing yet, but hopefully, assuming this mission is approved by our member states by the 3rd quarter of next year. Please, next. Okay, what's on the side of the Copernicus program? We of course mentioned Sentinel-1A and B. C is coming up towards hopefully early 2023 for launch. And as I said, 1D will come 25, 28. But what we have been discussing with the Commission, the European Commission and our member states, is to expand this first 6th generation of Sentinels. And we're looking at the expansion mission. For the while they were called HPCM, but now the decision is almost taken, and we'll be able to. The decision will be finalized in the coming months, and we'll be able to add 6 other type of Sentinels here. If you can go back, no, I'm sorry, I'm a bit too early here, too fast. Okay, so Rose L, so Rose, can't remember the acronym, but I'm sure Malcolm Davidson will be able to tell you. The I, of course, is for radar, L is for L-band, and we are foreseeing 2 satellites, flying at L-band. You see the bandwidth available. We'll be looking also for an option for a 3rd satellite still to be confirmed. You see some of the characteristics here, 50 square meters here in terms of spatial resolutions here. And, very important is the same orbit and acquisition geometry as Sentinel-1 in order to get, L-band and C-band. So really to achieve a 2-frequency system of systems here. Like all the Sentinels, we are talking of 7 years of nominal, because as you know, Sentinel-1A was launched 7 years ago, and it's still doing extremely well. We are looking more like, an average of 10 years, if not more, for each of these missions. Next, please. The mission objectives, of course, in terms of L-band, and you see some complementarity of what you could do between L and C-band here, in terms of ground surface motion, but also for for land application, forestry here, and also at the same time, Biomass will be flying here. So a fantastic type of instrument here, of missions that should come later in the decade. Next, please. Some characteristics here of the future SAR, Copernicus SARs here, and it's really, to work on the 2-frequency approach between the C-band of Sentinel and the L-band of Rose L. You see some example of what you can do in terms of, iceberg detections here. But it's going to be really to work on this combination here. And at the bottom right, you see the revisit time between Sentinel-1 CD and Rose L A and B, when we are more talking towards the second half of this decade here, and we are talking of revisit time of in order to get this to get data from either L or C band. Blue is around 1 or 1.5 days. Next, please. So after Sentinel-1, we are talking of NG. NG stands for next generation, so to be flown, early 2030 here. And of course, the key element here, and this comes from the user requirements, I recall the user requirements from for the Sentinel are, processed or handled by the Commission. Of course, they are looking at the Copernicus services, and it's to continue SAR data in order to ensure that these services can be ensured here. But we'll be looking at different things here on the Sentinel-1 next generation. But at least we will ensure that what has been achieved with Sentinel-1 will be guaranteed here. You see some of the characteristics here for this. The difference between continuity and what we call enhanced continuity. Enhanced will be more than the Sentinel-1. And it's going to be also very exciting missions. We are in the so-called phase AB1. We just launched the ITT invitation to tender. The phase A should start mid of this year. I'm sorry. Next, please. And this is the gives an example of what could be done in terms of the Copernicus in the future, together between the Sentinel-1 next generation here, which will carry on what Sentinel-1 has started, but also with Rose L at L-band here. and it will be extremely interesting here. I think you have some very exciting times here once L and C band will be available, and as I said, P band will be in 2029. I'm sorry, in 2023 with Biomass here. And there will be a lot of synergy here, but also it's not only with the ESA missions. Of course, we have many other missions. I was talking from our colleagues from the US with NISA here. There are also plenty of national missions which are also coming up here in the future, especially at X band here, and of course our colleagues from China are also very active. So I think it's coming to a very interesting time for the SAR community, but also of course all these systems will be able to handle interferometric capabilities. And I think with that, I think that's the last slide. And I would like to close, this short opening and really to, thank you for your attention. Thank you for joining, and wishing you a very, productive and successful meeting. Back to you, Marcus.
Thank you, Maurice. Okay, so I will show just the 3 slides about practical organization of the workshop. So my share button is not working yet. Okay. Okay, so do you see my first slide?
Yes, we see it, Marcus, but you are not in full video mode, huh?
No? Okay, just a second. Okay, so it should be better now.
Perfect.
Perfect. Okay, so I'm just quickly showing the participants our program this week. So we have a very dense and highly interesting program. We have more than 100 oral presentations and almost 300 posters, so 272. And I have to say that the quality of the inputs for this workshop has been excellent, and it's only because in an online event we can't really do so many parallel sessions, so we were not able to accept many excellent presentations as orals. So please, all the participants of the workshop, pay good attention to the poster sessions as well. So we have 9 thematic sessions, and we start going into parallel sessions Tuesday after the first coffee break. So the way this program is set up, that we have 1.5-hour blocks, and each block has a 15-minute question and answer, and this is done by a tool called Slido, and my colleague Magdalena will shortly explain how this all is going to work. So we have sessions starting on Monday, then we have discussions, poster sessions. We have one on Tuesday and one on Wednesday, and last one on Thursday. So 3 poster sessions. These gray blocks are the technical sessions, which is where we want your inputs, and we discuss in an open roundtable discussion on what the recommendations of the communities are. And then, like this has been customary in FRINGE, we present on Friday the session summaries in the closing session. So practical issues. So Magdalena will soon take over and explain how Brella and Slido work. So I would just like to make the comment that your inputs are really vital here. So please be active and use the collaboration tools that we have. And the thing that is for ESA is the most important outcome of this workshop is the outcome of the technical discussions that happen at Tuesday, Wednesday, and Friday, and we are gathering R&D recommendations for preparing for future missions that Maurice just showed us slides about. And okay, I think that's it. And Magdalena, you can take over.
Yes, okay, thank you. So I would like to show you a few slides regarding Brella, usage of Brella and Slido. So you know already this panel that I'm showing in this slide because you are here as you are watching us. So the most important tab here on the left, stream, where you are watching the streaming. If you want to change later on during the week, if you want to change between different parallel streaming, so different parallel sessions, you have to change the parallel streaming here in this tab above the streaming window. On the right side, you see the Slido panel. So this is the panel where you can ask questions, but not only ask questions, you can also vote on questions. So for example, if during the session, some questions were already asked and you would like to hear the answer to this particular question, you can vote on the question. In practice, how it would work with questions. So during the session, you can also ask questions during the session if you already have something to ask. But otherwise, at the end of the session or towards the end of the session, you can leave questions that we will address at the end of each session. So at the end of each session, we have 15-minute slot. It's the Q&A slot. And during this slot, you can write questions here on Brella in Slido panel, and we will we will pass these questions to the speakers. Okay, let me go to the next slide. Let me go. Okay. So the next tab here, which is very important, is schedule. So in the schedule, you can find all, of course, all the schedule of the event. And here, if you see, well, you see the, for example, opening session, you see just the names of speakers. But if you click on the name of the session, you have another window which is opening. And inside, you can see the exact schedule of the session with the hours, precise hours of presentations and speakers and title. On some days, so today no, but from tomorrow on, we will have parallel session. So in order to know where to find the streaming for the parallel session, we put just next to the name of the session, we put the name of the streaming tab. So Ice and Snow 1, for example, will be in parallel 1 streaming tab. So the thing that I showed at the beginning. So here you have directions where to go to watch the session. Next very important tab here is the People tab, which is used for networking. So for example, here you can write the name of a speaker or name of the participant that you would like to network with. You search a name and then, you click here on the button Suggest Meeting, and then you see the availability of a person for possible networking meetings. So here you can suggest to the participant that you would like to meet with him or her. So this is a very nice option for networking. And then next occasion, let's say to network is to, of course, attend poster session. So if you go to the schedule tab, you see that there is a session which is poster session. If you click inside, so on the name of the session, you see that each poster session is divided into sub poster sessions. So, for example, in the first poster session, we have advances in the theory, we have data products and services, and atmosphere and ionosphere. So to see what kind of posters do we have in the session, just click on this poster session 1A, 1B, or 1C, and then you see PDF with all the authors, titles, and most importantly, ID of a poster. So knowing who is in the session. You can select which posters you would like to visit. And then having this information, you switch to the e-poster tab. So you go to e-poster tab. Here you type or ID or the author name or title of the poster. Probably ID would be the easiest one, because some authors may have two posters. So just write here an ID of the poster that you are interested in, and then it will filter and find you the poster. So when you find your desired poster, you click on a poster. Okay, so you go inside the poster, and during the particular poster session, so here, for example, on Tuesday between 2 and 3:30, you may chat with the author of this poster. So you go to the poster, and on the right side, you have a chat where you can discuss with the author and other participants. So this is another way also for networking. And the last very important part of our schedule during the week are the technical sessions. So you will see in the schedule also technical sessions. These sessions are not streamed, so don't look for them in the streaming tab. In order to participate technical session, which is on WebEx, you have to go to schedule, like always, click on the name of the session, and then here in the description of the session, you will have here in the description, it's written, please click here to join the technical session, and it will take you to WebEx. It is recommended that you install a desktop version of WebEx. And in the technical session, you'll be able to also ask questions, not only in written form, but you can also be unmuted and you can speak, and we can discuss. So I think that's all from my side. We will also put these slides and some other videos showing how to use Brella on the main event home website. You will see there in documents you can find this this presentation as well. Anyhow, we have also our technical support. So you see the email also on the event home, and you can ask also questions to our organizing committee. Thank you. And now I will pass forward to next speaker, who is Pierre. Thank you.
Thank you, Magdalena. We are a little bit short on time, so we need to move forward. The next presenter is Pierre Botin, the Sentinel-1 mission manager, and he's going to present the Sentinel-1 overall mission status.
So good morning, everybody. Can you see the slide? It should come very soon in display mode.
It's starting to display. 1 second. Echo. Works.
Yes.
Yes.
Is it okay?
Perfect.
Okay. So thank you, Marcus. And we have 3 presentations related to Sentinel-1. I'll give you briefly an overall presentation on the status. And Bethlehem Rosich will follow with more details in the mission operations, events and operations. And then at the beginning of the next session, after the coffee break, Guillaume Hduc will present some details on the status of the product and the mission performance. So I'll try to be fast on this overall mission status presentation, since I understand we are a bit catching the behind schedule, if I manage to change. So I will just keep this general slide, which is related to the overall definition and mission fact of the Sentinel-1. And I assume most of the participants know
Sorry,
No,
Pierre, can you switch the display from the control so that we see your slides in the presentation mode?
Is it
Yes.
better?
Yes,
Is it
perfect.
okay? All right. So we have launched Sentinel 1A already 7 years ago, then Sentinel 1B 5 years ago. Time is flying, and now since a few years we are in full mission routine operations. I think this slide was presented already by Maurice, so I'll be very brief. I will just mention one point which is related to the COVID situation. Actually, we have managed during the COVID-19 crisis to maintain the mission operations as nominal, thanks to the effort of the ESA colleagues and at industry for the people involved in the mission operations. So we have nominal mission operations with a small exception, the fact that it was decided in ISOC at the Flight Control Center of ESA that we would limit the presence of engineers in charge of uploading the telecom and the mission plan to twice a week instead of daily. So it means that on the Tuesday and Friday, we upload the mission plan. So in case of emergencies, there might be, let's say, the possibility that we miss a couple of observations, but in practice, the impact was very minor on the mission operations. I will not mention those figures already presented. One important aspect is that in addition to the routine operations, so regularly we specifically task some observations to support the activation from the Copernicus Emergency Management Service and also from the International Charter Space and Naval Disasters. And when we have specific events like volcanic eruptions or earthquake, like it was the case for the Tal volcano in more 1 year and a half ago, and recently the China earthquake and the Nyiragongo Goma volcanic eruption, what we do is try to allow for a 6-day revisit in both geometries, ascending and descending, so that the events can be characterized, and this we'll do that for a few weeks or months. Just to mention that in addition to the operational activities supported by Sentinel-1 mission, the applications linked to the maritime surveillance, sea ice monitoring, emergency management, land cover, sea state domain. Actually, we have designed in the past the mission to be also clearly an interferometric mission to monitor ground motion with the subsequent, let's say, applications. So this is possible thanks to a predefined observation scenario where the interferometry voice mode is the default mode over land. And we ensure consistent planning in time with some data time series available. We have also a systematic production scenario. At the beginning of the mission, we were not supposed to process all the SLCs. It was made regionally, but with the high demand from many users worldwide, we have decided to process systematically in SLC, and this largely increased the volume of data to be processed and disseminated. We have a Copernicus data policy based on a free, full, and open data distribution, which is very good for the exploitation of Sentinel data. Then in terms of observation, we have a short repeat cycle of 12 days with 1 satellite, 6 days with 2 satellites. So it's possible to do interferometry at 6 days on some areas, in particular in Europe, or in some areas where we which are very critical in terms of ground motion. We have tight satellite orbit control operations. I'll come back on that. And we ensure in terms of mission planning, the burst synchronization to allow for INSAR. So I'll be very short on this slide, which basically mentions this interferometry voice mode, which is a default mode over lands. For instance, over Europe, we have very, very long passes made in one shot, where we required actually in direct transmission and pass through these long passes. In terms of orbit maintenance, I was mentioning that we have a tight, let's say, orbit control maintenance. We maintain basically the satellite in an orbit ground tract of a deadband of plus or minus 120 meter at the equator and the maximum latitude. These correspond to an orbital tube radius of 100 meter, as you can see on the figure. So this means that in order to ensure this very tight orbit control, we perform weekly some orbit maneuvers, in-plane orbit maneuvers, and every month, in average, some out-of-plane orbit maneuvers. And this is performed in a very routine way, systematic, and this is done since the beginning of the mission. So this shows the ground deviation, ground track deviation, where you see in red rows the lines. This is the plus or minus 120 meter on the ground. So, and you see the let's say deviation at the minimum latitude and the maximum latitude, and we are always we ensure always that we remain with this plus or minus 120 meter of ground track. There are a few exceptions in case we need to perform collision avoidance maneuvers due to some threats from orbit debris, and but these are very minor. This happens very rarely, and it does not really affect this scheme of short, let's say baseline, rolling short baseline for an interferometry. In terms of overall observation scenarios, what you see here did not really change since a few years now. We are optimizing there and there based also on some specific requests from Copernicus services, member states, and so on. And in terms of revisit and coverage frequency, as you know, we strongly focus on Europe, on the European Arctic, and for tectonic areas at global level, we ensure at least a 12-day repeats in both geometries, ascending and descending. So you get even more information on these slides. And don't have much time to go in more details, but this is available on Sentinel Online website. In terms of user demand, it's quite stable. This shows for the last 3 months the number of active users, the number also of Sentinel-1 published products, the number of Sentinel-1 product downloads. In terms of figures here, it's quite impressive, and you will see that the SLCs, of course, in terms of volume, represents almost 2/3 of the data which are, in terms of volume, of the data which are published and also downloaded. In terms of product publication timeliness, these show the figures that over the last months, and we see that you know that we have 4 distinct hubs depending on the type of users. Most of users use the open access hub on what you see on the left side, and there we ensure a very good timeliness. The requirement is within 1 day from sensing, and actually for 3/4 of the data we managed to publish within 6 hours, which is an average, which is quite good. Okay, well, I'll not go on the other figures, which is more related to the timeliness for near real-time services. For example, on the right side, for the Copernicus services, we have a very good timeliness for the data publications on the specific hub. On this slide, I have tried to list the various services from the Copernicus services where Sentinel-1 is used. And what is very good is that now we have a real service related to exploitation of interferometry, the European Ground Motion Service, which was in development over the past years and which has now started the production phase. So it's a systematic use of Sentinel-1 data over Europe for ground motion monitoring. And we had also the application of interferometry in some of the activities from the Copernicus Emergency Management Service linked to a risk recovery. And also for ice sheets monitoring INSAR was also used. But now we have this new very ambitious ground motion service. We have been working on the possible scaling of a 3-satellite constellation with some candidate options that you can see here. The option 1 and 2 were, let's say, suggested on either side. Option 3 and 4 was suggested by Copernicus services, in particular the climate change service dealing with ice sheets monitoring. I will not enter in many details, also regarding the performance in terms of maximum average revisit maps. What I would like to mention is that we have been consulting the Copernicus services to get their advice on the best candidate options, and there is a clear preference for the option 1, where the 3 satellites would be, let's say, balanced, located in the balanced way in the orbital plane at 120 degrees separation. However, recently we have, following some analysis on either side and in consultation with the European Commission, if we want to remain within the allocated budget for the Sentinel operations, we need to remain with the 2-satellite constellation, which is a baseline. So what we will do is that we will launch the 3rd satellite for Sentinel 1, 2, and 3. And in the case of Sentinel 1, the 1C will most probably replace the 1A, but we will keep the 1A in orbit standby in case of anomaly. So it's actually the first stage that we have a satellite in storage in orbit, and we are working on this aspect. So message here is that, yes, we stay with the 2-satellite constellation as the baseline for mission operations. And I would like to conclude with this very nice example given by Michael Froman, is from the Aristotle University of Thessaloniki in Greece. This is related to the important earthquake that took place in March this year in Timeliness in Greece. There have been actually 3 earthquakes, a major one and 2 replicas. And this demonstrates the performance of the repeat frequency provided by the Sentinel-1, where we could, let's say, identify each of these 3 earthquakes using the, let's say, the ascending path of certain dates separately. And then when you see the overall result of the interferometry from the, let's say, the baseline, the reference date of 25th of February up to the 15th of March. So this is about to characterize individually the 3 different earthquakes. And I think this, yes, this also is the same earthquake, but providing the ground motion, ground displacement maps in vertical displacement and east-west displacement. And this concludes this presentation. I thank you very much.
Thank you, Pierre. Yes, we need to move on.
Yeah. So I suggest that Bethlehem Rosic start with her presentation. So Bethlehem is, among many other things, she is the Sentinel-1 ground segment and operations manager. And we'll present more detail in the overall operations, mission operations of the mission. Please, Bethlehem.
Good morning. Thank you, Pierre. Can you hear me well?
Yes.
Yes, all good.
So I'll go through, try to provide you an overview of the operations status for Sentinel-1 and trying to focus on the aspects that I think should be more of interest of this specific community of users. So to start with, well, let's start with an overview of the timeline of the operations. And actually, it's already about 7 years we are in routine operations for Sentinel-1A and 5 for Sentinel-1A and 1B, so in a constellation operations. So it's what this means in reality is that by now we are in quite routine and stable operations for the mission, for A and B satellites and the overall constellation. You see here a snapshot of this of the timeline since the launch of Sentinel-1A. And a few things to highlight here. one thing to mention is that even if we are in, say, a routine operation since many years now for Sentinel-1, routine operations doesn't mean unmanned operations, doesn't mean operations where nothing changes. And actually, we have started what we have called the ground segment transformation in basically end 2018, and with some major activities last year in 2020, which have been aimed at making sure that the overall ground segment and the overall transformations were suited for the future as well. So the current setup we have today, you see that there is a sustained level of operations for Sentinel-1, a continuous level of acquisitions, production, data access operations. And to ensure the continuity of these smooth operations also for the future, there is the need to regularly put the question of what is the best setup for the operations? Are the operations sufficiently suited also to sustain the challenges that are coming next and to continue fulfilling the operations performance for the future? And when I'm saying what's coming next, it's what's coming next on the next, what we have called, what it's called the financial framework with the European Commission. You know that the Sentinel operations are interested by the European Commission to ESA as part of a Copernicus agreement. And this is organized by financial periods. We are at the end, in 2021, we are at the end of the current financial framework that has been in place since the beginning of Sentinel-1A operations. We are finishing this period and we are starting at the end of the year on the next financial framework, a new agreement with the European Commission for the operations of the Sentinels, which means as well a new financial envelope. That's what Pierre is mentioning, for example, is the discussion there whether we can afford the operations of a constellation of 3 satellites in orbit or the constellation of 2 satellites. This takes place in this as part of this agreement. And also as part of this agreement is what operations are expected to be covered during the next period. And this is definitively the continuation of the current operations, the launch and the integration operations of the CE units, and the start of the Copernicus expansion missions that will be coming next as well. So the operations of the ground segment are meant to be able to continue the current operations with this current performance and also to be suited to integrate and to host the future operations as well. So this to say that as part of these routine operations they are not routine operations where nothing happens. There are many things happening in these routine operations. And to give you an overview of what this operations transformation is, I'll give you an idea about that, because this is, it has an impact on the actual operations. It has an impact, hopefully a positive impact, we believe, in the operations that are experienced by the user from what the user can see out of the operations. And overall, the scope of this transformation and all the activities that are going on the operations, on top of ensuring the delivery of qualified and best quality products with the best performance to the users, is also to make sure that the operations are done in a way that they are efficient, that they are cost effective, and that can be maintained in the long term. So what you have here is a snapshot of the setup, what I'm calling here the legacy scenario. So how the operations have been organized basically up to beginning of 2021. And up to this point in time, we had specific infrastructure that had been deployed in a number of centers around Europe, supporting the operation, supporting the production. You see, for example, here the 3 core ground stations that have been supporting the operations of Sentinel-1 since the very beginning of Sentinel-1A launch in Palomas, Matera, and Svalbard, and a specific infrastructure was deployed there to sustain the near real-time production of Sentinel-1. The same you see here, 2 centers supporting the long-term archiving operations in UK and in Germany, and they were also supporting the systematic production of all the acquired data in what we call FAST 24, so meaning data available within 24 hours from sensing. You see the DRS operations, you see mission planning operations and similar operations that are performed at ESBIN, again with a dedicated infrastructure, same for the Mission Performance Center in Brest. And what is called here the Operations Control Center in Toulouse, where the current operator, who is Airbus, is performing remotely the end-to-end operations of the Sentinel-1 production. So this is the legacy scenario, which is very much, we're saying, in a traditional architecture with dedicated infrastructure deployed, and all these linked together through a dedicated Copernicus network, interconnecting all these sites. And in particular, this includes as well the data access operations that were deployed and operating using a dedicated infrastructure in Frankfurt. Now, through this operations transformation, we had a number of objectives. In particular, one of the objectives was to migrate all of production-related operations to a cloud environment. Not only production operations, but also the data access operations. And on top of this, to perform all data transfers through internet, thus removing the need for the specific connections and the specific hardware dedicated to the dedicated Copernicus network. The result of this is in place since April this year. Since April this year, we have a new set of stations, which happens to be the same as before, plus the Neustrelitz ground station. They are the 4 core ground stations in X-band are contributing to the acquisitions together with the DRS. There is no more any infrastructure deployed at the stations dedicated for Sentinel-1, but all the data that is acquired by the stations is made available on repositories, dedicated repositories operated by the stations, sitting on a cloud environment. All the production operations are since end of March also performed on a cloud environment, totally, I would say, totally cloud agnostic. This includes all the production, plus in particular the mission planning as well. And since April this year as well, all the data access operations have also been migrated to a cloud environment. So this is now a complete different setup, including as well the long-term archive operations that have been also moved to a new contractual setup, a new set of services that are interconnecting with all the other services through internet and through a repository that is also sitting on a cloud environment. So as a result of this, we have now an architecture which is far more flexible than what we had before, and which allows as well a much more easy and simple integration of new services into the overall system, and a new replacement eventually of new services through open competition, which is the way we are procuring the Sentinel operations. So this migration to the cloud and this new architecture comes as well with some, I would say, minor changes to the operations as experienced by the users. And one of these is the handling of the near real-time and non-time critical observations. So some words on this. The Sentinel observations, and Pierre has mentioned this, and probably this is known to most of the user community. Some of the observations of Sentinel-1 are performed with what we call a priority downlink. So these are what we call near real-time observations. They are downlinked to ground with a higher priority, and therefore they're on-ground as well managed with a higher priority, in a way that the products associated to these near real-time observations are made available to what we call eligible users, so typically the Copernicus services, within 3 hours from sensing. The same observations, the same near real-time observations, plus all of the other observations, which I'm calling here non-time critical observations, are as well made available to all users within these 24 hours from sensing. So in this sense, these near real-time observations have intrinsically 2 timeliness, one which is 3 hours from sensing for specific user communities, and one which is 24 hours from sensing for all the users. All the data, whether it's near real-time or fast or non-time critical, is systematically processed. I think that has been mentioned by Pierre as well into what we call the systematic production scenario. And this is a very simple scenario, has been evolving over time. Now it's a very simple scenario because basically everything which is acquired in high bitrate modes is systematically processed to level 0, to level 1 GRD, and to level 1 SLC. Over areas, over ocean areas, all data is also systematically processed to level 2 ocean products. And of course, for wave mode, this is systematically processed to level 2 ocean, and made available also as level 1 SLC as well. On top of this, we have some systematic regional processing on other different modes for specific product types. But I would say this is a very punctual and very specific processing scenario. So what is changing in this processing scenario now that we have migrated to the cloud? So to illustrate this, I'm starting here with an overview of how the production scenario has been operating up to March this year. This is what I'm calling here the legacy near real-time scenario. So if you think about all the acquisitions over Europe, which are performed in near real time, basically in direct downlink, so data is downlink in parallel to the observation being performed by the satellite. So data is downlink in this pass-through mode. And you see over Europe, we are downlinking the data over these core ground stations in Matera, Biomass, Svalbard, and now Nostrulit as well, which are overlapping to each other. So in most of the cases, an acquisition starts on the coverage of a station. As you see here in this particular example, the acquisition is starting in the coverage of Matera, and this is an ascending acquisition, so it's going up towards the north, and the acquisition then is finished over the coverage of the Svalbard ground station. As a result of this, there is a part of this data take that is acquired in a station and a part of this data take that is acquired in a different station. So in the legacy operations up to March this year, what happened was that the part of the data take that was acquired in each station was processed immediately after in a totally isolated, independent mode. As a result of this, we had a number of level 0 and level 1, level 2 products processed separately from each ground station in near real time. So this data was available within 3 hours from sensing, was processed using the state vectors that were embedded in the source packets. And as a result of this, the products that were generated from each station had no continuity between the slices. So the slices that were generated from Svalbard in this case, or that were generated from Matera, were not necessarily matching each other geographically and radiometrically because the processing had been done completely in an isolated mode. So these products as such in near real time were made available only to these eligible user communities, in particular the Copernicus services. And that was the first time this near real time, this data was processed. The same data then was processed again in what we're calling here the non-time critical mode as any other observation. So forgetting what had been done the first time, this data was then processed again. And for the second time, the data that had been partially acquired at each station was first put together, assembled together, and then processed as if it had been acquired all together in a single station. In this mode, there was the full continuity between all the slices, all the level 1 products is assured from a radiometrical and geometrical point of view. And on top of this, since this was happening, I will say a bit later, there was time to wait for the restituted POD orbits to be available. And the result of this production then was made available to the whole user community. So indeed, for the whole user community, the products that were available for near real-time observation were only this specific type of products. The near real-time were not distributed to the whole user community. So that's for the near real-time scenario and the overall production scenario in the legacy system. Since we have migrated to the cloud beginning of this year, in particular since March, this has been changed, and the way that it has been changed in a way to optimize the production and to avoid processing twice all the near real-time acquisitions, which account for about 40% of the data which is being observed by Sentinel-1. So in the new scenario, near real-time observations are only processed once and are processed in the way they were processed before in non-time critical, meaning the data is assembled before it's being processed, ensuring the full continuity between the slices. And this harmonizing the way the data is processed, whether it's a real-time observation or non-real-time observation, the production approach is exactly the same in both cases. The only thing that changes between the two is that for the real-time observations, the predicted POD orbits are used rather than the restituted POD orbits. For the rest, is exactly the same processing and exactly the same quality of the data that is being generated. Still, the timeliness for the real-time observations is maintained, meaning that for the whole user community, near real-time observations are now arriving, made available as well faster than that they were available before. There's no difference anymore in this respect. So if just as a snapshot of this, just as a recall of this overall logic in the legacy operations, as I was saying, the real-time observations that were processed separately using embedded orbit information and made available within 3 hours to entitled users, Copernicus services. And they were processed again in the standard mode together with any other observations and available to all users within 24 hours. Since March this year, basically, near real-time and non-near real-time observations are processed in the same way, with the only difference of the POD orbit being used, predicted, or POD predicted or POD restituted, and made available to the whole user community. I'm keeping here the reference of 24 hours because this is I would say the requirement against the service providers performing the operations for us are executing the operations. Still, as Pierre has mentioned before, and I'll comment on that as well, the actual availability of the data is far better than 24 hours in reality. As a statistical value, just to complement on what Pierre had mentioned before, if you look at the overall data being made available, is about 87% of the data is made available within 10 hours from sensing from the data access app.
Bethlehem, 2 minutes.
Okay, I'm hurrying up then. Now, in terms of mentioning this, the use of POD predicted and POD restituted orbits for this difference in the production. What you see here is a snapshot of the quality of these different orbits, and you see that for the POD restituted orbits, you have 99% of the orbits that have an accuracy in 3D accuracy of below 5 centimeters. And for the predicted orbits, it's about 93% of the orbits have an accuracy below 10 centimeters. So we are in the same order of magnitude in both cases. This orbit information is available to all users. It's available now through the Copernicus Open Data Access. There's a dedicated POD hub where orbit information is available. Restituted orbits are predicted orbits are typically available before the corresponding acquisition is available, and restituted orbits are available typically 1 orbit after the acquisition is performed. Just to mention as well that the complete orbit information has been, for Sentinel-1, the complete mission orbit data has been reprocessed and is now available as well for access to the orbit through the Data Access Hub. And this means that all orbit information is now have a homogeneous quality. The data that is the orbit information that is being made available now is consistent with this reprocessing campaign that has been completed. Maybe I'll go very quickly on this. I think this has been statistics that have been mentioned by Pierre as well on the performance and on the systematic access and the volume of data that is being made available to the users. Just to mention as well, perhaps here quickly, the fact that immediate access to all the products is available for recent observations in, let's say, API synchronous mode. And where recent observations means here is we started with a month following the migration to the cloud, and we are planning to increase the period of covered by immediate access to the last 6 months. Access to historical data has been also significantly improved in terms of performance over the last months. Basically now, whatever is for whatever user requests historical data is being retrieved from the DSs in a totally transparent way, manner for the user with the same API interfaces. And the data access for historical data is ranging from few minutes to few hours, and this depends on the system load. So what next is this evolution is actually a continuous evolution. So you see where we are now, that's the scenario on the left, and where we are heading to is to, by beginning of next year, we have still a different scenario, different setup evolved from today, where for the Sentinel-1 production in particular, we have two different service providers performing the Sentinel-1 operations productions on the cloud, one for Sentinel-1A and one for Sentinel-1B. Of course, ensuring the same processor baseline being used in both cases, but there will be two different service providers. Also to mention that the data access, that's also a service that will be renewed by the end of this year. So there will be a new data access service provider still provided on the cloud. With evolved features with respect to the current data access of today, we are aiming at having a future data access operations that includes as well the DS functionalities and the data access, traditional data access functionalities. And also to mention the plan to have an operations dashboard available by the beginning of next year with some functionalities that will be available for consultation to all the users on the status of the operations in an interactive way, up-to-date status of the operations. So what's next maybe in the last minute is there will be some evolutions as well as some more concrete evolutions coming in the next months, in particular a new processing baseline that is ready and that we plan to put in operations in the coming weeks. So for that, I will suggest you to follow the news on the Sentinel Online. There's updated product format specifications to come that comes with this new baseline, some sample products, and also the news for the schedule for the operational switch to this baseline that is planned in weeks' time, so that time sufficient for the user community to adapt to the new specifications and to check the sample products. There are also some, what we are calling extended time annotation auxiliary files that have been developed. The integration and operations of these auxiliary files that should help in improving the accuracy, the timing accuracy of the SLC products, and therefore for all interferometric applications are planned to be in operations, I will say, in full operations within 2022. We'll have a preliminary time-limited operations campaign towards the end of this year with some sample data that will be made available to users, and the routine operations will really come next year. We are also planning to put in place an on-demand production capability based on level 0 and the latest processing baseline. That's also plans for next year. And of course, the commissioning of Sentinel-C, and as Pierre was mentioning, the new constellation with the C unit in orbit. And overall, what's really planned next is the continuous enhancement of the Copernicus operations and the Sentinel-1 operations, of course, over the following years. Thank you for your attention.
Thank you, Bethlehem. So as you can see, there are major changes taking place on the ground segment with this transformation, which is behind the product themselves. You don't necessarily all the changes that are performed, which are huge efforts, which are mandatory in order to sustain the mission operations, not only with Sentinel-1 but with the other Sentinels. I understand, Marcus, that we need to keep the question on session, right? Because of the time.
Yeah, we are a bit late, so we don't have a QA session time slot here. We have to take most of the questions in the next after the end of the next block. There's one question that is both to you and Bethlehem, but I just read it from here. So, are there steps in place to try and increase exposure of ESA, collectively the usage of SAR, INSAR, etc., in member states that appear to be lacking in this?
Well, we must say that with this first ERS and NVSATs, now Sentinel-1, the interferometry is a key applications, definitely. There have been some efforts made on the R&D side. by the applications department to try to actually support some new innovative applications based on that antiphonmetry. I'm not sure I fully understand the question in the sense that, yes, I mean, this workshop like FRINGE are definitely aiming at, let's say, further democratizing the usage of SAR data for ESA applications. I think what is very good is that at European level, the fact that we have a new Copernicus service that will drastically change the, let's say, situation in terms of exploitation of INSAR data. Besides that, if the question is not completely related to INSAR, we are working on the new, let's say, standard product, analysis-ready data product that we that could, let's say, be available within a couple of years, indicatively. Let's say, basically trying to put even available even more easier way the Sentinel SAR data to users and more the general public actually. So this is there is an ongoing activities on that to define precisely an European standard for in line with the CEO's Cart4L to define an analysis ready data that could further, let's say, allow to make use of SAR data. I don't know whether you want to add something on this.
Thank you, Pierre.
Marcus or Bertrand?
I think that we need to go for the coffee break because we have to start the second part of this session at 11. So coffee break now, and we restart streaming at 11. Or I guess the stream stays open. Okay, so see you at 11.
Thank you, Marcos. Thank you all. Thank you, Pierre.